Okay, hope you guys have been enjoying the Fanfest a lot and been having a good time here. And I'm sure the quiz show was pretty fun for a lot of you who saw it last night. We're not going to be as funny as that, but Mindstar will give his best. Okay, so today the presentation is on tranquility on HPC, high performance computing, making a mountain out of a molehill. As you can see, the concept is taking Eve, the TQ server, and moving it up to high performance computing. And there's many reasons that we need to do that, and we'll get into that throughout this whole presentation over here. So how this all started kind of is, I think a few of you who were here last year or saw some of the videos and presentations, is that you saw Hilmar give us a challenge. And that challenge last year was to come up and change what the whole performance of Eve is, and to change all your experiences with Eve, to make this as smooth as possible gaming experience and get the epic fleet fights that we all really want. So we took up that challenge this year. And today will be the culmination of kind of what we've been going through, and we'll also show what we're planning on doing in the future. And during today's presentation, there's myself. I'm the IT director at CCP. I'm Queeg 500. We have Neil Foster from Microsoft right over there, who will get up and explain our partnership and a little bit about high-performance computing on the Microsoft side and where they're going. And we also have Mindstar, which a few people know who can rap very well. And he is our virtual world project manager. So he is the one taking on the challenge of testing and rolling out HPC and also all the performance changes that you have seen recently within the cluster itself. So without further ado, what we will do is I will go to the next slide, and what this next slide will be is our concept of what we wanted for HPC. Because when we're given the challenge of what we want to do, we have to come up with what our idea will be. And I think it was Mindstar who actually jumped up when the first thing they said, and he said, fleet fights must be over 9,000. So we took it to the next level, and we don't think 9,000 is enough, so we went with 10,000. So as you can see, and we will kind of explain, a lot of this may seem like this is way overboard. You know, whenever you see like fleet nodes of 5,000 or 10,000 people, or a little system called Jita having more than one CPU running it, so we can get a few hundred people in. And the market nodes, of course, as we would like to, of course, grow the market, and as we add people to the cluster, the market's only going to be used a little bit more than what it is now. So we have a whole lot of systems over here to take care of. Well, we have over 5,000 solar systems within Eve, and we have over 300,000 players, and I think our PCU is a little over 41,000 players online at the same time. And there's no reason that we can't hit a lot more than that, even 100,000 or more. So what I will do is I will turn this over to Mindstar right now, and I will let him explain a little bit about the cluster and where we were and where we're going to.
Thank you. All right, so we've seen that fantastic diagram prepared by Queeg here of the cluster as we'd like to see it. Fleet nodes over 9,000, Jita running on multiple CPUs, etc. But what I want to really go through with this presentation and give you guys a feel for is what we've done in the last year. So what I'm going to do firstly is just show you what the Eve cluster looked like in November 2007 at the last Fanfest, when we really kicked off the drive for high-performance computing. So the cluster then was quite simply a three-layered cluster. First, oh, that would be backwards. I've got to learn how to click forwards. Okay, there we go. So we start with the internets. And the internets are connected to some load balancers in our data center in London. And our load balancers then connect to a bunch of proxy blades. Our proxy blades are essentially glorified software routers, which then provide interconnections between the player and we've got about 100 Sol blades at the moment. Now the Sol blades are where all of the processing and the simulation of EVE Online gets run. So all spaceship combat, all market transactions, all chats, everything that happens in EVE is calculated on a Sol blade. Finally, the Sol blades connect to our database cluster. And the database cluster itself is a presentation in and of itself, so I'm not going to go into too many details on that. But the database cluster is essentially where all the storage of EVE Online is. So whenever the Soul Blade has to look up, what ship you're in, how much ammo you've got, it has to talk to the database cluster. So in November 2007, we were running a set of technologies on this cluster that had grown over time with EVE. Some of them were a little bit old, some of them needed replacing. So the first one of those was the network layer, which was the method that our servers used to talk to each other, especially the proxy blades and the Soul Blades. This is just a specific proprietary method of communication. And that worked very well. It was working quite nicely for us back in 2003 when we were peaking at 10,000 players online. But it's not a very, very scalable system. And as we're hitting 40,000 plus users, it started to show its age. Similarly, our Soul Blades, which were running state-of-the-art equipment when we bought them, running AMD Opteron 2.8 gigahertz, which was the best processor that we could get for EVE Online when we bought them, getting a little tired. There are some new advances in processor technologies from Intel, and we want to be able to take advantage of those. So, also running Microsoft Windows 2003, very stable operating system, nothing wrong with it, but there have been a lot of advances made in the last 5 years, and with Windows 2008, we want to be able to take advantage of some of that. Similarly, all of the EVE servers were running on 32-bit software, meaning that there's a limit on how much memory they can address, which ultimately limits the number of people we can put on one Soul Blade. And they were running 2 nodes per Soul Blade. Single CPU core per node. This is one of the main things that we need to be able to address to really, really grow EVE. Essentially, the other limitation, apart from the amount of memory that we can address, is how much processing we can do per node. Now, unless we can get more CPU cores in, there's only so many megahertz available in a CPU. And the way CPUs are going these days, they're not going to be getting any faster. The CPU manufacturers now are going to multi-core, quad-core, 8-core systems. So one of the projects that we need to work on as a part of this all is replacing the single core with multi-core. All of the hardware networking is 1 gigabit networking, just plain old TCP/IP Ethernet. And that, once again, when the EVE cluster was originally designed, was fantastic. But as we get more and more users online, we're straining the CPUs more and more and more. The network needs to be extremely low latency so that communications between proxy blades and Soul Blades are as fast as possible. And finally, running the database cluster on Microsoft SQL Server 2005. SQL Server 2008 is out now, and we want to make sure that in our pipeline is upgrading the database server. So, to take this to HPC, what do we have to do? There are a number of elements in this that really need to be just completely switched out to make sure that our cluster is running once again at the cutting edge, at the bleeding edge of technology. And so the improvements that we need to make are replacing JetByte with a new networking layer so that we have a properly scalable networking system that allows our proxies and Soul Blades to communicate with each other and does not have the issues that we found with JetByte as it started to grow. Similarly, we can actually reduce the number of proxy blades. With JetByte and with a large number of users, we were discovering that there were some slight instabilities which would cause proxy servers to die from time to time, disconnecting thousands of users from the game. So part of the reason that we had a large number of proxy blades was not actually because of the sheer amount of load on them, but for redundancy. With some of the improvements that we're making to the cluster, we can actually reduce the overall number of proxy blades. And that is actually very beneficial, and I'll come into this a bit later. We also need to replace every single Soul Blade. We want to replace the entire cluster with brand new hardware. We want to get rid of our AMD Opterons, and we want to go with some much faster next-gen CPUs. The ones that we're looking at the moment are the Intel Xeon 3.3 gigahertz Wolfdale CPUs. As far as the megahertz race goes, these are about as fast as we're ever going to see for the foreseeable future. So that's what we're looking at the moment, and that's what we've been playing with. Similarly, Microsoft Windows 2008. There's a very good version of Windows 2008 which is extremely useful for Eve called the core version, which essentially rips out the user interface and a lot of the memory overhead that goes into running the Windows operating system, and is a console-based command line version of Windows, and that runs Eve very, very nicely. Windows 2008 also has a replaced TCP IP networking layer. So even before we can replace our 1 gigabit Ethernet with something better, we can take advantage of better, faster networking with Windows 2008. We replace our 32-bit Eve code with 64-bit Eve code, which means that we can then remove the limit on how many players we have in system at the memory level. We can address just huge amounts of memory with this. And with the change to the dual CPU Soul Blades, we can run 4 Soul nodes on one blade. And then finally, or not finally, but the other thing we need to go to is multiple CPU cores. We've got these faster processors, but even so, you can only bump up the speed so much, and every time we just get a faster processor, we just raise the limit of where the lag hits. So of course all of this is part of our just war on lag, on server-side lag, and we can just raise it and push the limits a little bit, but ultimately we need to break those limits. To really hit the massive scale that EVE Online needs to go to, we need to get multiple CPU cores per node. The last thing that we really want to do is to get rid of the 1 gigabit Ethernet within the cluster. We need to get a better networking technology. And at the moment, the network technology we're looking at is InfiniBand, which runs at 20 gigabit per second. Now, the main issue with InfiniBand, or the main area that appeals to us with InfiniBand, is not so much the sheer amount of bandwidth, because 20 gigabits is a huge amount of bandwidth. It's actually the latency in between the nodes on the cluster. Going from 1 gigabit Ethernet to 20 gig InfiniBand, you can take latency from something measured in milliseconds to something measured in microseconds. It becomes almost as fast to access something on a blade across the network as it does to access something internally for the CPU itself. So for where we want to take the cluster, being able to have just this lightning fast networking is thoroughly important. And then of course upgrading our database layer to Microsoft SQL Server 2008 is also on the horizon. So that's kind of where we're wanting to go with the cluster. Those are the steps that we need to take to get there. And as you can see, there is quite a big difference that we're planning to make. And between November 2007, which is last year, and where we want to go is just a huge difference. So what I'm actually going to do is I'm going to invite Neil Foster from Microsoft to come up onto the stage now. Oh, Jon Carlos is going to come by and introduce him, because he's got some fabulous things to say. So I will pass the clicker thingy back to Quig 500.
Okay. Thank you, Mindstar. As you can see, there's quite a lot of differences in what we want to do. I've talked with a few people, around about supercomputing around here and around other places. We've been to supercomputing conferences, and we've really dealt with a lot of good business partners over the year. And we're doing things that other companies aren't doing. The supercomputing world is mostly your academics, the people doing aviation, those type of, and automobiles, those type of real hardcore intensive calculations that can be set that if they die, it's okay, you restart it. It may take another week, but you can actually restart it and nothing is really broken. But with EVE Online, I don't think the players would like a few reboots every day. It may not go the best for us, so we have to worry about a lot more redundancy than and fault tolerance than the other people within the industry. And more or less, we're doing a calculation of a universe. And what the neat thing is that everyone here, that are doing missions, you're doing fleet fights, you're doing market orders, you're doing contracts, you're doing all these things that is changing the environment within the whole universe. And more or less, this is on-the-fly supercomputing. So we can't run this in a structured way where we have certain jobs that'll start in certain areas on the cluster and things like that. We have to really plan for these. And so we're really on the edge of technology. We're doing something that no other place is doing right now. And a lot of companies are actually probably scared to go into this direction because this is in an area where companies, such as Microsoft, IBM, Voltaire, all these people are having to get their best people together to help us through this. And this is what's leading me into the next presentation is our partnerships. We have wonderful partnerships within CCP and within the high-tech community. Currently, right now, as Mindstar talked about, we are looking at InfiniBand. We're currently going through and testing Voltaire switches, which actually are the exact switches that are in the top computer within the supercomputing industry today. It's the #1 computer. They are using that one, and that's what we're testing, basically due to the fact for the latency. So, and we're also testing the Intel CPUs right now for all of our systems. We do have AMDs now, and it's the flow of how the industry is going. As Mindstar mentioned, we're going to 2, 4, and 8 cores, 16 cores, up. Who knows, how far they'll go. But the problem is with Eve right now is that I think as a lot of people here know is we use Python. Python, of course, we are limited by the global interpreter lock, which is leading us to single-threaded applications, which means basically means we can't use a ton of cores and a ton of sockets to run the processor through. So we have our core team actually working on that part. Moving to supercomputing is going to be a slow, gradual process, and it's something that we need to have the people in the top of the industry, just because there's no applications out there that can really handle what we're doing right now. So why Intel? Because Intel, they do have the 3.3s. They do have some 3.5s, which I'm trying to pull out of our wonderful IBM vendor over here, trying to get us some special blades, if that's at all possible, or the 3.3s if we can't pull that out. But we're working with people to make us special equipment to help us through these times. And so Intel is keeping with the faster CPUs, and they are dual core. So we are working within our core team to try to get Eve to run at least dual core if that's possible. And they're working on those type of things right now. So we can take full advantage of those. Now, in the future, once we do become completely multi-core within the Eve process itself, things may change. But that's where it'll take a lot of testing and a lot of effort for us to do. It's not something we can just throw up on the cluster and test with all of you guys. I don't think you would like that either. So I've mentioned IBM a few times, and we've used IBM servers from the beginning. They are a sponsor here. We have one of their banners over there. And they are a sponsor here at Fanfest. And we plan on continuing with them in the future. Everything's been wonderful with them. And we have, the speaker who I will bring up real soon right here is Neil Foster, who's our HPC partner for Europe. And Microsoft, we've been with them from the beginning as well. We have a wonderful relationship with both of these two companies. And we've had a lot of people, especially going to the supercomputing conferences, they're like, you're not using Linux? You're not using Unix? What the heck are you guys doing? And what's interesting is I always can say to them is that I don't see any other company doing what we're doing on Microsoft and IBM hardware. So, it kind of shuts them up, which is really interesting for computer geeks. So over here, I will introduce Neil Foster, who we've been in the Microsoft TAP program for the HPC server. The TAP program is a special program for companies like us that they want to be business partners and make sure that they can move into this industry as well. Because the gaming industry is not something that is really thought of with HPC, and nobody has really taken our needs into their systems or really thought about those. So we have been in pre-beta, more or less. That's what the TAP program is. We get in from the beginning of the development of the HPC server, and we have done testing from the beginning all the way through. It was just released, I think, a few weeks ago. And so over here, we have spent the last year testing and letting Microsoft know what we want and what we need out of the cluster, and working with them on what possibly other gaming companies and other companies that could possibly use the same type of technology or the same way that we do. So without further ado, Neil Foster, who will come up here and explain a bit about Microsoft.
I think I'm switched on yet. Am I on? Yes, I'm on now. I can hear myself. Well, good morning. I'm very impressed. I know I struggled to get up this morning, so I'm very impressed with everybody there. I'm Neil Foster. I'm the HPC Partner Manager in Europe. I won't go into the way Microsoft's organised across Europe, but my task in all this is actually to create partnerships with companies around HPC, particularly from my perspective, with companies doing new and novel things. So hence my interest in CCP games. HPC normally stands for high performance computing. Unfortunately, our marketing people have got there and have now started to call it highly productive computing. But what's interesting is the industry's actually started to pick that up, so there's an element of truth in that. But what I just give an outline, try to get too formal, but just what I'm going to go through. Just like to go through why are Microsoft in this industry? Because as John Carlos said, it's predominantly a Unix or Linux base and has been big iron, supercomputers, etc. And Microsoft haven't been involved in this industry for a long time. So give some reasons why that were there. Just a brief overview of the server. I'm not a techie. I know a little bit about it. I'll tell you a little bit about HPC Server 2008, and then just talk a little bit about our partnerships. So, main reason why we're in it, there are some certain business drivers which everybody has to address when they're delivering a product or a service around here. First one is competitive advantage. It's a big reason why people are using high-performance compute clusters or behind is they have to get their product out before the competition, or they have to give a better service out, etc. And CCP is one of those that is leading in this, in the sense that they're trying to give you a better service and give the whole environment a better service. So it has some unique attributes which HPC can help. Pressure to improve operation. I'm sure you've all got jobs. I assume that because you're all here and have had to pay to get here. One of the things I'm sure that your management's trying to get you to do is you have to do the job you were doing last year better, quicker, and probably for less, whether you like it or not. But that pressure's on everybody. It's on the company's products. And just trying to do that is a good reason for sort of using the likes of a HPC cluster, whether that's designing a product or service, whatever. You need to make sure that you get it out to time, that it's built with quality, and it will work when it's done. A lot of people don't know, obviously in the industries, there's different industries with compliance. I'm not too sure CCP games have a compliance in this, but I think the compliance is driven by you, the users, in the sense that you want a solid service. You don't want reboots. You don't want the system going down. So that's a good reason from that perspective. And also innovation. John Carlos has gone through in the way the infrastructure around Eve is changing. And I think what's very obvious from the presentation is that change is continuous because of the changes that are going on in the industry. Multi-core is having a major impact on the industry. A lot of people still don't really understand really where that's leading to. It was great when CPU chips were single and you kept getting faster. Every year you got another 20, 30, 40% speed up. That was really great. You could do things cheaper and faster and quicker. Now you can't. You can get more, but you have to operate differently. So this year we're seeing, we've got quad cores out now as a fairly standard. We're going to see 8-way cores very, very soon. And who knows where that goes. Probably in 2 or 3 years' time we'll be seeing 16 20-way cores. That's going to be a big difference to the market. Not quite in here, but so high-performance computing. I say normally it's about speed, and to do this, people used to have, as I termed them, brains the size of the planets trying to get this to work. Basically, there was a lot of problems with high-performance computing, and particularly once people started to use clusters as a standard form, and I'll talk a bit more about that later. But actually, getting a bunch of computers to talk together and to operate together is not a simplistic task. It takes experience, it takes a lot of tools, etc. And that has been a big, if you like, little drag on the development of that. Around that. And historically, if you go into a lot of companies who use HPC, the automotive, the car manufacturers for designing cars, or the aircraft manufacturers, or drug companies, you tend to find the HPC system is set in a separate department. It's got a specific set of users, a specific set of tools. And if you do that sort of thing, it makes it very difficult to actually integrate that within the whole IT environment, which actually puts people's costs up, reduces all that. And of course, at the end of the day, also, most of you will need applications if you're going to use this. CCP, EVE Online is an interesting application in its own right, but if you're looking at most companies out there, what applications are actually taken up for this? For the vast majority of applications are written on the basis they're single-threaded. There are several within the computer-aided engineering area and drug design which are highly parallel. Genomics is a good example as well there. But actually, if you look at particularly many of the business applications, how can we try and drive that, and how can we actually start to drive that? So these are all a lag, and this has been the big problem for there. So why can Microsoft help in all this? Well, lovers or loathers, we are everywhere. We're in more or less every data center in some shape or form. It may only be an Exchange server or a version of Office, but we are everywhere. So, and we do work with many of the major companies around the world in trying to help them get the best out of their infrastructure. So we are there. We know what sort of pains people are going through from that perspective. And as I say, HPC tends to be isolated from that perspective. And we've got tools which we can help to do that. I only joined Microsoft 2.5 years ago. I used to sell Linux clusters, and people thought I'd gone across to the dark side. But actually, when you come across to Microsoft, you can see a whole new set of technologies which we have, which actually help and support the whole environment. And so that's a big plus from Microsoft around that. Of course, we've got some obvious tools, people like Visual Studio, Active Directory. All these tools actually go into the product that we're using in some shape or form, and we can actually help with that. We are a big company as well. I mean, unfortunately, we can't deny that. But actually, that means that we do spend a lot of money on R&D. We spend a huge amount, billions. And we have our Microsoft Research Labs, and we have product development. So obviously, the HPC server is part of the product development. But also in Research Labs, we're doing lots of product development around novel and new programming paradigms, etc., particularly the parallel processing. Trying to do parallel processing, and I can go back to fortunately, I can go back to the mid-'80s, and when it was first coming out, parallel processing in supercomputing environment. It was not an easy task, and it's changed over the times, but what actually it requires a lot of skill. I mean, actually, programming for this is quite difficult. So actually, we're working in terms of trying to define that, working with the industry, trying to understand the new ways of doing that. So we do have a big parallel programming initiative. And of course, actually, from the high-performance computing, we're trying to get that in place in terms of developing the product so that actually make it easier to use. So the vision. As I say, high-performance computing historically has been about speed. I've got to go faster. To be honest, we're not really going to affect that. Predominantly, that's driven by the chip manufacturers and some of the programming paradigms, obviously, but predominantly, it's a hardware-driven issue. But where we can help is in terms of the integration. So my pitch around Microsoft is not so much about making it go faster, but making it easier to go faster, both easier to use, easier to manage, easier to integrate, and easier to develop on it. So the three sort of communities we're addressing here are the people like John Carlos's team who administer the environment. And we've got to make it easy for them to manage that environment. We've got to make that task because they are doing regular updates on it. They're doing changes. And if we don't give them the tools to do that, if you've got several hundred servers, trying to re-image those, it can be a major task if you're not given the right tools. It can take hours, if not days, and I'm sure some of you have tried that. So we need to get the tools there to make that easy. For the application developers, again here at CCP, we've got to give them a set of tools so that when they're developing code, they've got the right tools at hand to help them, A, parallelize it and use it, but also to debug it and work out where problems are, how they're using memory, how the I/O is, etc. So these tools are being a constant development, not just by Microsoft, but a lot of the partners. We do work, and I'll say that more in the end as well, work with partners in terms of there's a lot of the compiler technologies and debugging technologies which are actually driven by partner companies. And finally, the end users, you guys. We want to make sure, maybe you're not thinking you're running on a supercomputer when you're more interested in the game. You're more interested in what's on the screen and what you can do. But actually, we've got to make that experience, both for you or for the people designing cars or aircraft, we've got to make that experience very easy. So one of probably the big advantages for ourselves is that, yes, a lot of people use Windows, and we're trying to make high-performance computing a simple extension of that. And that's really where we're coming from. Just a little view of really where we're going. in here. And really, I won't go into the details because there's lots of bits and pieces. But I think what the interesting thing about this is, yes, we will develop some core parts here. So, and I've got the right thing, yes. So we will develop the HPC server, and I'll talk a little bit more about that there. And we've got a lot of other products, the administration products, whether that be System Center, whether it be SharePoint, Excel. Excel is the new high-performance computing application, by the way. You may laugh, but it's true. It really is. I mean, there's a lot of banks there, and they've got Excel jobs that run for days around that. But also partners in here, whether that's in terms of administration areas, sort of the job areas, development tools particularly, but also in things like storage. If you've got a big cluster, you've got problems with your storage. You tend not to want going through a single NFS server, otherwise you could be waiting a long time. So, brief overview, HPC server, simple on one slide because that's about fits in with what I can describe. Actually, HPC server in its basic format is just Windows HPC Server 2008. It's nothing more. It's just the 64-bit edition. We made a decision right at the beginning of the first release, Compute Cluster Server, to only support 64-bit. You can run 32-bit on this, but we're only supporting a 64-bit edition. And the reason for that is, if you're into high-performance computing, you're going to need more than 32 bits of address space. You're also going to need more than 32 bits of processing space as well around that. So we're really only supporting the 64-bit, which predominantly that's all the hardware vendors make nowadays. And we also, the other side of it is, actually, it's quite a secure and reliable operating system. Whether you love us or hate us, it is. It's secure. It is reliable. And what we've done on top of that, back. Oops. That's it. It was double. And what we've got on top of that is what we call HPC Pack. So the whole idea is, take a basic operating system. What do we have to put on top of it to give you a compute cluster environment, a managing cluster out of a box? Basically, what we've added in that, a couple of things. One, a job scheduler, because normally these are big jobs. It's not just one person using them. You've got lots of people fighting over resources. They want their jobs far more important than the other guy's job. They want more CPUs and more memory than the other guy because they deserve it. So we put a job scheduler in there to cover that. We have all the things around resource management. We've got to be able to manage those resources. We've got to give the tools to people. One of the big things that we did in this is we put a command line interface, because when we first started to develop this code, we had to get, what are the things we have to do on a Windows operating system to get into the, if you like, the geek mentality. And the thing that came out on top was we have to give a command line interface. And that was the base of the resource manager and cluster management tools. The other thing we did, one of the tools for running over clusters, one of the implementation tools, is message passing interface. This is the way all the CPUs, all the processors can actually operate and share data and share jobs amongst them. Now, there's a standard for this. It's actually called MPitch2. It's set up by Jack Ungar. It's a whole open source organization. It's been going around for many years. What we've done is we provided a Microsoft version of that, MSMPI, which was a complete open source development. We took it, we did a few changes, we put all those changes back into the open source. I think some people are saying it's probably Microsoft's biggest contribution to the open source. But basically, we took that, gave it back. Basically, the changes are all around security in there. But the whole idea is that people take their existing their MPI applications and port them across to this, or take codes with MPI-based parallelism and port them across in an easy manner. The two together actually is what I try and sell to customers. It's quite boring. All I'm doing is selling a bunch of operating systems, and that's really all it is. So just what's new in it? It depends what you thought about the old version. You may not know. The actual old version was based on Server 2003. I'm not going to go through it, but there were some fairly important ones. One that's very important, there's a couple of things that are very important to CCP games. One, head node redundancy. If you have a head node and it falls over, single point of failure in our old version, major catastrophe for all the gamers, I'm sure, if we went out. So we've actually we've now got head node redundancy. That's basically using a SQL database with redundancy there. So if it does go down, it picks up all the jobs that are running and carries on. That was a major part there. The other interesting part is really around the networking. And I'll show some things. Basically, we provided a TCP/IP stack for the networking. It allowed the cluster to do what it said in the box. I'll give you a cluster. But I think we'd have to be honest and say the performance wasn't as good as the network stack that's been around for the Linux systems and Unix systems. And so a couple of years, and I think we've got some pretty impressive stories to say about that. That, of course, has a big impact in terms of CCP games in terms of helping with the lag. And that's actually some of the things that we can help with around on the GigE. It actually makes GigE look a lot better. We're doing things with storage, around iSCSI, around that. And finally, on job scheduling, the big difference there is historically, HPC is a batch processing job. You put it in, wait for the answers to come out, and then you run it. The whole paradigm's changing. People are working differently. So we've actually allowed now for service-oriented architectures. So we've got a broker system where we can take on lots of interactive jobs and do it. So maybe it's lots of technologies like this that Microsoft have that part of the reason for the partnership with CCP. They're doing things differently from a HPC perspective, but they're just doing things differently with our technology. And we actually find that not just in HPC, but elsewhere. I mean, you laugh about Excel, but actually Excel is used far more in far more extreme ways than I think most of the developers ever envisaged. Right. So a little bit of history. Though it was Server 2003, we weren't 2 years late getting it out when we delivered the first one in 2005. Let's go back. As someone said, well, taking Microsoft. I mean, yeah, it took us some time, but we actually, when we first developed the first version, we decided to use Server 2003 because it was a stable, reliable operating system. But actually, we built our first system, brought out a beta on it in the winter 2005. We had 4 processors. This is actually Kirill Feinhoff, who's our director of product development. And he's very pleased with the fact he's got 9.46 gigaflops out of those 4 systems. I think most people with laptops now could probably beat that. Around that. But obviously, it's a start, it's a journey. And really, these other ones are all talking about a story around that, what in the HPC land we call the top 500. Top 500 is an interesting story in itself. This is basically a site which is set up to basically capture the top 500 systems across the world. And it's sort of gained sort of a cult status. Actually set up by Jack Dongara, and they issue the list every 6 months, and you have to put the job in and get the process. And you can imagine lots of universities and labs vie to get their position. Which does make it an interesting selling exercise for people, I must admit, around that. So our first foray into this from the Windows perspective was down here back in spring 2006, where we got the National Center for Supercomputer Applications in the US using 896 cores. We got to 4.1 teraflops, and we were actually 130 in the list, which at the time was fairly impressive. Actually, a year later, we have our own internal system here. This is 2048 cores, 256 nodes. And with a InfiniBand backend. We got to 9 teraflops, and we got to 106 on the list. Didn't quite break the 100 mark, but we got to 106. So we're fairly proud about it, but But actually, if you look at it, and I know I had comments made to me, it says, that system is, yeah, it's got there, but it's not as efficient as those around you. And my comment to people was at the time, look, this is our first release, our first product. We're only, at this point, we'd only had the product out on the street for about a year. And it was my comment back is, look, one thing about Microsoft is it'll tell you how it's going along. We're not hiding anything. This is the story and the state of the art as it is. So I said, you just wait. So this is spring, and then at the end, in November at the Supercomputer Conference, we did use exactly the same box, but we moved from Compute Cluster Server to HPC Server. And guess what? We went from 9 teraflops to 11.8 teraflops. Only problem was we actually slipped down the list, which I think is indicative of the way the top 500 list and the way supercomputing, high-performance computing is actually going. So we were actually down to 116, but we got a significant improvement in efficiency, network efficiency, and that was a major win for us. This last spring, we actually announced some others, mainly university ones. I know Umio quite important. Clearly, I was actually involved in this. And that's interesting about this one. We came in at 46 teraflops. I think it's a bit more than that, actually. But we came in at 40 on the list. But most importantly was this figure, 85.5%. The most efficient system in the top 500 list. And actually, I think someone worked out, there is now the green 500. And someone worked out that gives you more flops per power. So it's the greenest computer on the planet, which does leave a little bit to decide when you think it's chomping up megawatts of power. But anyway, and it's actually an IBM computer. I should say that. It is actually an IBM system. I worked there. But we did get another one on the list. There we got 68.5. So we're not at the petaflop, which is this year was the first year that was announced, but we're getting there. Though at the end of the day, I will say from a Microsoft perspective, whilst it's great to get these, it gives us a lot of profile. Actually, the main aim of this is to make it easy for people on their desktop to take advantage of HPC. So my request to people like yourselves is, if you're killing your desktop, if you're doing computational tasks on your desktop today, you're the people we're really trying to get to, because we want to make it easy for you to use high-performance computing, to just extend it off your desktop. If you're doing computational tasks on your desktop, it interferes your interactive tasks. That's my message in all this. And really, that's really where we believe the opportunity is, in terms of making it easy for people in a Windows environment today to actually look at having a cluster to extend the desktop and actually improve their own productivity and improve the productivity of the company. But we have a whole list of other partnerships, both in terms of the hardware vendors like IBM, etc. We're working very closely with and the infrastructure vendors, people like Intel, AMD have been mentioned, Voltaire, etc. Because we all have to work together if we're going to get there. But the other side is for me, is around the software companies. We're working very hard in terms of trying to create an ecosystem so they are actively supporting us. So we've got a whole range of them. And I think that covers it. But as I say, if you want to find out more about it, the easy slide to go to, easy place to go to, Microsoft.com, sure you've all been there, /HPC. And you'll find out more about it. Thanks very much. And I'll pass you back to Mindstar, I think.
Thanks very much, Neil. So, I guess what we need to look at now is what it all really means to the players of EVE Online, because ultimately the most of the HPC project is something that is very much just going to be between CCP and Microsoft, and the end result is going to be what happens for you guys. So, one of the things that's worth picking up on is that in the last year, we have been working very closely with Microsoft. We've been involved in their technology program, their TAP program, and working hands-on with the version 2 of HPC. And what we've learned from that, and what we've learned in the last year, is that there were a number of technologies in November 2007 in the cluster that we needed to replace before we could even hope to move EVE onto HPC. And so what this year has focused on for us is both learning HPC so that we know a lot of the idiosyncrasies of HPC internally, and working on the systems that we needed to replace to get the EVE server up to speed so we can put it onto HPC. And the great thing about that is that we've managed to roll a bit of that stuff out, and even without going forward with the supercomputing project and without actually putting EVE on a supercomputer yet, we've seen some very, very big improvements in EVE. So the first thing, of course, that we've done this year to go from November 2007 to November 2008 is we replaced JetByte with Stackless IO. I'm sure you guys have probably seen some of the material that's been on the forums and in dev blogs, and we've replaced this network layer, and immediately we saw a number of changes within our cluster, some good, some bad, and we've been able to address those, and we've actually got a very, very, very stable networking layer underneath the EVE application now. Now, one of the drivers for getting Stackless IO on was that JetByte did not support properly 64-bit computing. As Neil mentioned, Windows HPC is a 64-bit computing environment, and so to get onto HPC, we needed to be 64-bit. So that was one of the key things that really, really pushed us into replacing JetByte. So with Stackless IO, we were able to start compiling 64-bit versions of EVE that worked. So the next thing we did when we got Stackless IO on there was we realized that with a much more stable networking environment, we were able to cut out some of our redundancy from our proxy layer. Now, that might sound like a strange thing, but what that actually means is that whenever one of our Soul Blades is talking to a large group of players, for instance, in a market hub, in a fleet fight, it has to go through all of the lists of proxy blades and essentially address all of them. So if we have, we were running 22 proxies previously, And this was actually causing a lot of extra work for our Sol blades every time they send out network packets. It was only a tiny bit, but essentially by reducing the number of proxies, we reduced the amount of work that they had to do to talk to players. And as soon as we cut out half our proxy servers, we went from 14 to 7, we saw a 5% CPU reduction across our entire cluster. And that was without any change in code or hardware or anything like that. It was literally just turning some proxy servers off.
Just a second, James. I think we've just proven that size does not matter.
Something I've been trying to convince people of for quite a long time, I can assure you. So reducing the number of proxy blades has shown a marked improvement in our cluster in the last year. Similarly, we've started testing some new stuff. We have started pulling out some of our AMD blades and putting in some Intel blades. Our hardware supplier in Iceland, our IBM supplier, has been very, very good in keeping us up to date on the latest improvements and the best stuff for us to use. And if we say we need to get 10 new blades in London, they generally have them in the mail before we even ask them. So we've got our new dual CPU Intel Xeon 3.3 gigahertz servers in place. We've currently got a bunch of those in the cluster that have made their way in over the last couple of months. These are now capable of running 4 64-bit Eve nodes on them. So we can essentially double the amount of Eve that we can run on one server just by going from 2 to 4 nodes per server. And they're also running Windows 2008 Core, so we're starting to take advantage on these machines of the upgraded networking layer. These are also InfiniBand capable machines. If this is the environment, the hardware environment that we end up using, we don't have InfiniBand on our cluster yet, but it's just a case of opening these things up, plugging InfiniBand in, and we're good to go. So we're really starting to get to the level of hardware as well that we can start to push on the true HPC environments. So that's where our cluster is now. We've made a few changes. We've sort of moved quite a long way along the path of being able to get Eve onto HPC. But what does that actually mean? Where are we now? We can't leave the cluster as it was in November 2007 for a year and a half, for 2 years, while we say, yes, HPC is coming, InfiniBand is coming, wait and we'll give it to you. Because the fact of the matter remains that there are areas in Eve which were virtually unplayable at some times. So we needed to be able to demonstrate a marked improvement in performance in some way. And so by laying this groundwork, by getting some of this stuff tested and out in the cluster now, we've actually managed to make some really, really good increases in performance in the three key areas of the game where we've seen the biggest performance issues. The first one, of course, is jitter, which I'm sure everyone knows. This time last year, it wasn't perhaps the best place to find yourself on a Sunday evening. And you might have to make the odd call to a GM for a little bit of help to get you out of there. Then mission hubs, level 4 agents, they're very popular, and within Empire, these mission hubs are actually the highest CPU load in our cluster. It's a slightly different type of load, but the mission hubs, even though they've got less players in them, they really, really hammer our cluster's CPUs. And so the main metric that we can look at in mission hubs is the module delay. And we can see how long it's taking to activate modules, how much lag there is on your modules. Then fleet fights. Now, fleet fights are the hardest thing to measure because every fleet fight is different. It's got different numbers of players. It's got different numbers of capital ships. It's got different numbers of drones. And so the fleet fights is more a sort of a generalistic number and something that you kind of just get a feel for based on seeing results of fleet fights over a period of months. So the first one we'll look at is jitter. In November 2007, it was feasible to get around 600 pilots in jitter before we started seeing issues, before we started seeing the petitions start flowing in and people needing to be moved out. And the problem with that was that more than 600 pilots wanted to be in jitter. And so one of the things that has improved in the last year with these changes is that we can get 850 pilots in jitter now before we start to see issues. Now, I think that's a pretty good improvement, to be fair. So it's almost 40%, or it's just over 40%. I guess it depends how you look at it. But getting 850 pilots in Jita now, and the first weekend that we actually had it running on this new hardware, the GMs were sort of sitting there going, "Well, what's wrong with Jita? Where are the petitions? Is there something wrong with the petition system? We're not getting any."
We're serious too. They were actually logging onto Jita to see if something was wrong over
Is
there.
something wrong there? So that's something that we're really pleased about, that we've been able to bump up the number of players that we can fit in there. Then, of course, mission hubs, module delay and mission hubs back in November last year. We were seeing the really heavy hubs like Motsu and Sailor. There were complaints on the forums all the time. I'm lagging horribly. And part of that could be attributed to the actual JetByte networking layer, and part of it was just to the sheer load on the system. And so in November 2007, the general number that we were seeing was that at peak times you were getting sort of 20 to 30 second module lag when you were trying to activate things. Today, you could go to one of these systems at pretty much any time and activate any module you like in 2 to 3 seconds. So we've managed to reduce that by a factor of 10 with these improvements. And finally, playable fleet fights. Now, this is probably the most contentious set of numbers that'll come up on slides, and I'm sure there will be people that agree and disagree with me. But for the most part, what we were seeing in November last year was that you could get a playable fleet fight with around 400 pilots, give or take a few. Sometimes people were having entirely playable fleet fights with 600, but there was usually something different about their fleet. That's total. This is total. So 200 aside, essentially. So when we've had these fleet fights, we've had a lot of this new hardware running for a couple of months now. There've been initial teething issues with them, and there've been the odd node death in some of the fleet fights lately. But in the last few weeks, we've seen that we can actually support up to 1,000 pilots in a fleet fight and have it entirely playable. So it's a pretty insane improvement, I think, in the number of fleet fights. And there've been both the hardware optimizations, the networking optimizations, the proxy server optimizations have all contributed to it. And we've also had our software teams working on some of the lower level areas of code and just putting out little fixes as we go. And those have also been responsible for this. And that's why there's a slight discrepancy sometimes in the fact that Jita went from 600 to 850, while fleet fights went from 400 to 1,000, because the areas of code that were addressed don't necessarily affect Jita and a fleet fight system the same way, because the load on Jita is often market and item inventory and things like that, whereas in a fleet fight it's mostly combat calculations. So we at CCP are really excited by these numbers, and these numbers, once again, it's worth stressing, is us pushing the limits, is us really just trying to push as far as we can with the existing paradigm that we've got with single core processors and without supercomputing. And we're yet to break them. I think we can, when we get multi-core Eve running on Microsoft HPC, I think we will actually smash these numbers. I honestly do. So where do we go with HPC from here? We've got some good numbers, we've had some good improvements this year, but we do actually still need to deliver on getting HPC out. And so one of the projects that we've been working on, and now that the version 2 of Microsoft HPC is out, is we can start looking at doing some public testing of HPC. We do have HPC environments with InfiniBand, with the full server layout that we want running. And so we're going to look at getting a test server together where we can actually run HPC publicly. So the main goal there is that we can get Eve running as it is now. So we've got our improvements that we've made. Now let us start putting Eve straight onto HPC. We may not be using some of the new networking technologies. We may not be using multi-core. But if we can get Eve running as it is now, we can then start to take advantage of some of the features of HPC and this rapid development. We can once we've removed the barrier of getting Eve onto HPC, we can start developing. We can start putting out smaller, faster changes and just do it a bit at a time. And so the first stage of that is getting this public test cluster together and getting the players on there, having Armageddon days, just trying to hammer it, and essentially finding out what breaks. Then From there, we can start to address our challenges. We know of a few challenges at the moment. One of the things that Microsoft addressed in this version of HPC is the fault tolerance on the head node. There's another area within HPC, which is the networking layer of MPI, which is essentially not fault tolerant, whereas if we lose a node from that, we lose the cluster. So that's an area that has to be addressed, and between Microsoft and us, we're going to find a way around it. SQL Server 2008, we want to get Eve on SQL Server 2008. And then finally, load allocation within the cluster. With the different paradigm of HPC and all of the vast changes that we've been making, we can actually look at how we're assigning systems and load within the cluster and tweak that as well. So these are some of the challenges that we hope to overcome. I think I've got one more slide. Yes, constant improvement. Even while we're on this map of getting HPC tested, we're still going to be delivering improvements within our cluster. We found that we've got the hardware that works, and we've got a little of a bit of it in, but we want more. So we're going to get some more of these Intel blades that we've put in. We're going to make them faster and better. We're going to continue testing CPUs. You've got new technologies for CPUs coming out. You've got the Intel Nehalem technology, which is not out yet, but the first chance that we can get, I know that our supplier is going to be delivering us blades so that we can put them straight into TQ and see which is better, Wolfdale or Nehalem. Then more performance.
He knows now.
Sorry?
He knows now.
Yeah, yeah. Consider that an order. Okay, so I think my mic's working again now. I think it slipped off. So more performance with the hardware improvements that we're making a lot of performance improvements, and that is in our Quantum Rise expansion. We've released the first part of that in these low-level improvements, and we can attack this from every perspective as well. Things like a game design perspective can come into it. The weapon linking feature, which is being introduced in Quantum Rise, is actually engineered right from the server load level, so that when you drop 6 or 7 guns on top of each other, the number of networking calls and the number of calculations that the server has to do internally is reduced a lot. And then finally, we're going to be working on getting multi-core Eve. Even if it doesn't coincide with getting HPC out, we want to at least be able to use our dual-core processors and be able to run different parts of an Eve node on 2 CPU cores. And I think these 2 features are things that will help us sort of push the limits some more. And so that's kind of where we're at. And I think it's best to hand over to Jan Carlos again, who will finish off this presentation.
Thank you, Mindstar. Yeah, so we're running really close to 12 o'clock now, so I'll try to keep this last part really short, so everyone can go see the PvP. They'll probably be setting up and all of that, so it'll be a bit after, I think 12:15 or so. They'll probably, or a little bit later, start. So, as you can see, we have a lot of things that we've been doing, and there's been big changes between last year and this year, just in this 1 year, with a lot of people working hard, and this hard work is not stopping. This is all part of the war on lag, and this will be going probably for years, as long as we keep getting players and people want to do more and more things, and we keep adding more things to the game. So with our partnerships and with all of our testing, we should hopefully have some very exciting things coming forward to everyone. So we're out of time right now, and we wanted to take a few questions. But we can only do about 5 minutes of questions, and then we will head out. Neil, could you come on up here, and we'll turn on all the mics and.
Whoa, we can have a competition.
Okay.
I'm also booked for the PvP at 12, so I have to just let them know I'm going to be a little bit late.
Yeah, so we'll do that. So, okay, let's start over here.
Firstly, a nice presentation, thank you very much. Going back to your Visio on your cluster diagram, are you using InfiniBand as a service bus?
As a service bus? The main goal for the InfiniBand is just literally, I'm not, myself is more the hardware side, but the goal with InfiniBand initially is just going to be lower latency network communications rather than a specific application level bus.
Yeah. Could you bring up the slide with the mission hubs?
Yes, go for it.
It seems on that slide that you haven't I mean, everything is lagging and the improvements are small. So it seems to me that you haven't split up the code responsible for chat, local chat, versus marketplace versus combat.
Okay, we actually have the market nodes. They are we have actual market nodes. You know, not everything runs on one solar system itself. So we do have systems and we do have certain processes split out. Now we are working also on where can we parallelize, you know, the Eve code itself. What can we take out of those processes?
Yeah.
Some parts of the code are not related. I mean,
Yeah.
chat is not related to combat.
This is a very good question, because the at the moment there are a lot of services which are not related, which are still calculated within the same Python thread, and so part of that is being able to split these things out but still keep them in sync. Sorry, this is horrible.
Yeah, so these are all being worked on by our core department. We have low-level programmers, you know, that work on the core of Eve. They're the ones who actually wrote stackless I/O, and they're working on, you know, the low-level network for the database, as well as the graphics, as well as the code itself. So
this seems more like a high-end or a high-level.
Right. We all of this has to kind of work together whenever we make this, because we can't just we just can't throw out InfiniBand into there. Right now, the MPI won't work. We have tested. We've brought the server up onto MPI, which runs great, but then we take it off and we let it run on TCP after that. The reason is due to the fault tolerance. Now, do our core developers have to work on our own fault-tolerant MPI, or do we work with Microsoft and other vendors, or the MPI forum itself? We've had some talks with them on working about redundant MPI, or, well, fault-tolerant MPI. So all these things are in development, but these are things that the industry itself is not at yet. So it's a lot of things, especially with like the Python.
Thanks.
Yes?
So the examples about the performance of the systems the last few years. How many teraflops does the server go at the moment? How fast is it?
That's actually something that I do not know off the top of my head how many teraflops our server is.
Yes,
It actually changes on a daily basis, because we constantly adding and removing stuff pretty much every day, taking things offline, putting things on.
Yeah, the reason that we haven't is because you have to actually run a test to do this. So what we would have to do is that we'd have to actually unload Eve off of every system and then run the test and see how it runs. And you know, if you guys don't mind us taking it down for a few days to reconfigure it, we would we'd love to do that. But we will actually, you know, when the plan is, when we do set up the full supercomputing cluster, is to actually at that time run a supercomputing test. Hopefully, you know, I would love to be in the top 500 to be at least the fastest gaming cluster in the world. So, but then at that time we will have the total teraflops and exactly the efficiency and all of those numbers.
You've talked about double data rate InfiniBand. You know that there's quad data rate InfiniBand and ConnectX InfiniBand?
Yes. And the various different flavors of InfiniBand are essentially nothing's decided on at this point. If it's feasible to go to things like quad data rate and ConnectX, then at the time when we're looking at investing the serious amount of money that needs to be invested to do the full cluster replacement, that's the sort of time when a decision like that will be taken. Currently, the switch we've got, the network cards we've got, they support the double data rate.
Yes.
Twofold. First, do you have any indicators moving the cluster?
Well, the time frame, well, what we're doing is that we're moving into public beta soon, probably right after Quantum Rise. We will be working with our QA department, because right now, of course, they're strapped trying to test Quantum Rise to go out. I think on the 11th is what it is, something like that. And right afterwards, we're going to hand them over our InfiniBand actual HPC system, let them test it and make sure everything works. Then what we're going to do is that we're going to try to move, the goal is to move CC over. It won't be InfiniBand. In the beginning iterations won't be until we can actually utilize the full networking layer itself, because you know, it's a lot of money to actually upgrade the switches and everything like that. These are not just a few $100s. These are a few $100,000 switches.
That's actually a good point to make, is that we don't necessarily need to be running on an InfiniBand level network to actually have the cluster using HPC and Microsoft HPC. We can still do that over our gigabit Ethernet.
Can you bring back that slide, the public test slide?
Yo. Oh, you've got it.
Yeah. So right now, the HPC one with InfiniBand is public facing, and we will probably open that up on our routers sometime for testing as well. And getting CC over to, actually running Microsoft HPC. We're working on slowly moving the cluster over now to Windows Server 2008, the core version. And then once we have the whole system running on that, then our plan will be to upgrade that to the HPC. And hopefully nobody will notice much of a difference, except possibly a smoother experience with the whole system running on Server 2008 core.
Yes. Have you done any calculations of how much of the performance you gain will be used for more people and for new content? Because I'm thinking this walk in the station, for example, will also generate a lot of more.
Right, walking in stations, that's a really good question. And
customization with the database load, have you budgeted 50% for more performance or 50% for...
Well, walking in station is going to be its own little animal, and we haven't really gotten into it's not really difficult for us once we know exactly how they want to use walking in stations. It's still really in development. Will they have their own servers? Will they have their own, will they share with what's in the system or parts of it or those type of things? Those will all be drawn out. And by the time we release walking in stations, that will have them, but we just haven't gotten into that area yet.
Yes.
What are the plans for handling ship battles, since you fly around on through different nodes and such?
The plans for that are things that are in the hands of our very, very gifted and talented core network and core programming team. And I wouldn't have the first idea about that myself.
But the ship battles, are they gonna be prioritized on the better nodes, or?
The question of prioritizing nodes on battles. One of the things that we do aim to be able to do with HPC is being able to do things like shift a system from one node to another without actually breaking the experience.
If you're not in bulk, can you book that in advance?
Yes, you can. Currently, if you and this is something that I did mention in a dev blog a month or two ago, if you do have a large fleet battle coming, please feel free to file a stuck petition with the GMs. Let them know the sort of numbers you're expecting, what time it's going to be, and what system. And as long as there's a downtime in between, we can actually make sure that we can try and get that onto one of these better systems. We're hoping to make it dynamic. In the future, we're hoping to have every system once again running on the same hardware, so it won't matter. This was a little bit, if we can just advance this slide by about, yep, that's it. Load allocation. That is one of the things that and the challenges that we're planning to address.
Yeah. Until we get the whole cluster up, we can't really predict where there's a fleet fight.
I must just interrupt. I actually have to run now, so thank you very much, guys. I'll leave you in the hands of John Carlos.
Yeah, so I'll just finish this question, then I'll let everyone else go as well, so that way they can do that. If anyone else has any questions, what they can do is that they can just catch any one of us at any time during this. So, thanks everyone for coming, and I can